I want to give a backstory just about my name. So my last name, Xiong, it means bear in Chinese, and it's pronounced Xiong, however you choose. I couldn't hear the difference. And I got married recently to a guy whose last name means peaceful rice field. And I'm very tired of being the last of the alphabet. So I thought, why don't we combine our last names into this one, the Bearfields? And now I get to have my talk right after coffee break, and Arvin gets to have his talk right before lunch. And he'll be the one holding you from lunch and not me. So thank you, husband. And my work is really at the intersection between data visualization and human cognition, human perception. And if there's anything I'd like to take with you today would be this message that visualization design matters. I know you probably heard this, people say this from time to time here and there, but I have some concrete examples I'd like to show you today, and we can think about some questions that I have and challenges in this space. I love some joining of forces to solve together. So here's my first concrete example. Here I have a chart depicting the COVID case trends in 5 counties in Georgia. So let's take a moment to look at this together. What is the first thing that stands out to you? What do you see here? So what y'all might be thinking, or is that a hand? Yeah, exactly. What y'all might be thinking is that there's this very salient downward trend. It looks like the COVID cases are getting better, right? But then you probably took a closer look at this point and you realize that the x-axis values are not sorted by time. They're actually sorted by size, right? So this downward trend is misleading. But this visualization is created by the Georgia Department of Public Health. They didn't create this visualization to deceive you. Actually, they created this visualization to help you notice on which day there were the most and least number of cases. But it wasn't very effective because the downward trend is very salient. Now, I offer you an alternative design of the same visualization. Now, I'm grouping the data by county, and I'm sorting the x-axis by time. Now, the pattern that stands out to you now is that there's a bimodal distribution of case over time. But then the problem with this visualization now is that it's now extremely difficult to determine on which day there was the highest versus lowest number of cases, because that requires you to do mental math to pick the bars and add them together to see who comes up on top, right? So what we're seeing here is that these two versions of the same data visualized will help you see very different patterns in the same data set. Now, it seems really easy for me to stand here and critique a visualization almost post hoc. We have to recognize that the visualization creation pipeline is quite complicated, right? You have data that reaches some kind of data scientist who then visualizes it and creates interactions for you, and then it reaches some kind of information consumer who then interprets the information. But this pipeline, in reality, looks more like this, because designing a visualization really involves a series of design decisions, and each of these design decisions can afford a different interpretation. And I have another example to show you what I mean. So let's imagine a world where we have different groups of people and they make different amounts of money. Right? If I were to take this reality and visualize it using this bar chart I'm showing you here, which we see everywhere, right? Bar charts are everywhere. What's going to happen is that the average viewer looking at the bar charts will think everyone in the purple group makes more money than everyone in the green group. And that's an inaccurate representation of reality, and that can lead to stereotyping. So if we were to visualize this reality instead using this jitter scatter plot, so in other words, we explicitly show the variability within groups, what's going to happen instead is that people are going to become less likely to make these stereotypical assumptions, and they're going to create a mental imagery of a reality that is more similar to the actual reality. So with these examples, what I want to say is that this research space where we try to understand what design leads to what interpretation is an enormous space with a lot of potential opportunities and open research questions. And what I'm envisioning is we can eventually build and create a model that can help us design better visualizations by predicting what a person will see or take away from a visualization. So the designer can adjust the visualization or to more clearly communicate what they want to communicate. see how this might work in action, right? So imagine you create a chart and you plug it into your model and you ask your model, what do you think the most intuitive takeaway a person might see would be for this visualization? And that model might predict that, well, it's just cluttered spaghetti, so your viewer is probably going to be confused. So you go, okay, sure, I will improve this visualization to look like this. And now you feed it to your model again, and your model will look at this visualization and say, well, looking at this visualization about how people get their news, it seems like your viewers are most likely going to say that people mostly get their news from television, because from theories of visual perception, we know that people like to focus on the top left corner of a visualization. So that's pretty good, but you're not quite satisfied because you have something very specific you wanted to communicate to your audience. So you continue to iterate on your model, on your visualization, and you feed it to your model again the third time. Now you highlighted one specific trend in the visualization, and now in an ideal case, your model would be able to predict that when people are looking at this visualization, because of the highlighted trend, they're going to say people are more increasingly relying on the internet to get their news. Right? So that's kind of the model pipeline that we're trying to build using trying to model saliency of data visualization combined with verbal takeaways that people extract from visualizations. So you may be wondering now, because there's a lot of movement in AI these days, you may be wondering how well can state-of-the-art models do in terms of this pipeline. And we've been doing some benchmarks lately, and I want to just give you a quick example on how GPT-4 can do this. And so what we did is we took very simple visualizations like this, and we showed it to GPT-4 and humans. So this visualization is showing you the price of different drinks in two bars, bar A and bar B. And if you're a human, I'd like you to take a moment and think to yourself what you might see as the most interesting, intuitive comparison between these very simple data points. Now, I won't put anyone on the spot just in case, but if you're human, things that you could be comparing while looking at this might be, you might want to compare the same drink across two bars to say things like, drink 2 is more expensive in bar A than it is in bar B, or you might want to compare the overall price of drinks. You might want to say drink 1 is more expensive compared to drinks 2 and 3. Right? So these are valid comparisons that when we crowdsource humans, they tend to do this kind of comparisons, very intuitive. But then, if you're an LLM, in this case, if you're a GPT-4, what you're going to do is that you're going to compare this very interesting, unique comparison that says drink 1 is the most expensive drink at bar A compared to drink 2 and drink 3. So you're going to compare the leftmost white bar to the other two white bars to notice that they're about equal, where the leftmost is the biggest one. Now, this is a factually correct comparison. It's semantically correct. It's not wrong, but it's just not what humans intuitively see as salient, right? So if you rely on a GPT model to predict what humans will intuitively see from a visualization, you might get something very wonky like this. Right? So state-of-the-art LLMs, they can struggle to predict intuitive takeaways from visualizations. And what's really interesting that we found is that LLMs, they are not sensitive to spatial design manipulations the ways that humans are. So for us humans, when we look at these 4 visualizations, we'll see they are the same visualization, but they are spatially arranged to look different. Right? There's a vertical, overlaid, adjacent, and stacked version of the same visualization. But human sees a difference. But then for a language model, it doesn't. Right? And what's also interesting is that language models, in this case GPT-4, is much more sensitive to the data context compared to humans. So if I were to take this visualization that's about vehicles and their durabilities, and I show you a version of this just relabeled to be about companies and revenue, what's going to happen is that humans is going to look at these two visualizations and say, okay, I see the same pattern across both visualization. It's easy. This is just a relabeling of the same data set. But then to an LM, these are complete different worlds of visualization and data set. And we just tried multiple configurations, things like we tried different models, we tried different temperature, we tried different specifications, like what we feed, what kind of code do we feed the LMs, and whether we give it the visual and the code or a combination of both, and whether we do different types of prompts. We didn't try all the prompt space because we can't, but we tried a wide range of configurations, and it just did not perform similarly to humans across the board. Right? There's more to read in the paper, of course, What I'm trying to say is that I think there's much more work that is needed to be done if we want to build this model where we can predict human takeaways from visualizations. Now, we can also reverse engineer this pipeline so that we can use it to generate visualizations based on some kind of human takeaway. For example, right, imagine a designer can ask a model to build a visualization that shows this specific message, and the visualization, or the model gives you a really beautifully designed visualization that will help people see exactly that message. So in this case, everyone's happy. Now, we're working with researchers from Tableau to make this happen at a greater scale. And here I have an example of Tableau's Ask Data interface. Right? So in this interface on Tableau, what you can do is you can type in a natural language query, and Ask Data will give you a visualization that best answers your query. Now, to perfect tools like this, we run into some challenges. This is what I'm here today to ask you for help. And the two challenges that we run into is that, well, it is very difficult to predict what patterns people see in a visualization. And it's also very difficult to understand what they're saying with their natural language, because language can be ambiguous, so interpreting their language specification can be difficult. So I'll talk more about them. I'll start with challenge number 1. So to kind of illustrate what I mean when I say there are many patterns and it's hard to predict what people see, I have an example for you. So here is my made-up data about 2 student government group election on campus. And you can see the historical data of the past elections outcome from years 1, 2, and 3. The y-axis shows you percentage support the 2 groups, the Green Party and the Blue Party, has received. And my question for you is, who do you think is going to win in year 4? Green? Hey, I see some blue. Yes, right? So I am a blue believer. Thank you, Judy. Thank you. I think you all kind of see what I'm trying to demonstrate here, right? Some of you might see this increasing momentum of green, and you might think green is going to win because it's decreasing its gap between itself and blue. But some of you, like myself, might see that blue has won every year. Blue has won recently. Why wouldn't blue win again, right? So we are focused on different patterns in the same visualization, and we're seeing different things and ultimately coming up with different conclusions. So when I threw these visualizations in front of crowd workers on Turk, this is what they see on this little voting spectrum. So on the left, you have people who think green likely wins. In the middle, you have people who think there's going to be a tie. And then on the right, you have people who think blue is going to win. And you see this very interesting bimodal distribution such that people are pretty split on what they think is going to happen. Now, what's even more interesting, I think, is that when we take the same data point in this visualization, which only has 6 data points, and we visualize it as a table instead, so same 6 data points, and we give people a table, what do you think happens with this table? If I were to ask a different group of people to vote on who they think is going to win, what do you think the voting outcome is going to look like upon looking at this table? More blue, right? And that's exactly what we see. So what happens is that because we change the representation format, the increasing trend in green just kind of disappears. There's no more momentum for them to see. And so with this, I hope I'm kind of convincing you that it's really hard to predict what people will see in a visualization until you do empirical studies to test it out one at a time. And even 2 people looking at the same visualization, they can see different things and they can draw different conclusions. And you have these concepts of like visual features or bottom-up saliencies. They matter, but people might generate different takeaways nonetheless due to their motivation or experience or background knowledge. For example, right, I have a colleague whose school football team is just always the rank 131 out of 131 teams. Back when I was at UMass, that was our team. And because of that, they really want to believe in the underdogs. And because of that, whenever they see an underdog gaining momentum, they want to root for that underdog. And so when they looked at this, they really wanted to believe that green is going to win. So it's really important for us to think about how one's interpretation of a visualization might be changed by these top-down factors, like their motivation or their belief. Right? And I have another example for you to kind of understand how this works in visual analytics or in statistical learning. So imagine you have some data points on a scatter plot, and you plot it out, and this is what you see. So you draw a mental kind of correlation regression line around these points, and you realize, okay, the data that I collected is not very correlated. Correlation is not very high. And then you realize, wait a minute, I'm a researcher who does environmental engineering, and this is data I collected about air quality and a number of environmental regulations. And I'm really experienced in this area, and I really think that air quality should become better as we have more environmental regulations. So what is happening here? These two data points on the bottom here that I highlighted, maybe something is wrong with these two data points. That's gotta be it, right? So maybe we toss them, and maybe we'll just draw our new mental regression correlation so that it looks better. So this confirms more with what I think should happen. Right? And we asked the question of like, how much does this actually happen in visual analytics, right? Maybe people are not actually doing statistics by ruling out the outliers, but just perceptually, are they discounting these outliers, and are they just making different impressions out of the same data set? And so we run a study, and we just asked people to estimate correlations when they look at a very neutral scatter plot versus a very just labeled scatter plot, where you may have beliefs for or against it. And what happens is that, I'll just walk you through the effect size. Let's imagine you have a baseline of a visualization with a 0.5 correlation. If a person looking at this, they don't have any hypothesis, and they don't think there is any way these two variables would be related, on average, you would see like about a 0.4 correlation. But if they're really invested and they want to see a positive correlation, they'll see a 0.6 correlation, right? So there's about a 0.1 correlation amount of difference depending on their belief. Right? So with this example, you can imagine when people look at a visualization, they can be subjected to these cognitive and perceptual biases. And so if we want to build a model that predicts what people take away from a visualization, we have to figure out what people see in a visualization first, right? So this is kind of going to be like Jeremy Wolf's visual search model, but 5.0, where we account for all of these visual factors. Now, I'm going to move on to our second challenge here, which I refer to as the language challenge. So if we want to understand or model what humans take away from data, it is going to be a lengthy process where we analyze human takeaways when they look at visualizations. And I tried to be lazy and tried to ask LMs to do this for me, but it turns out LMs really couldn't. And we wrote this paper on it. But so in order to do this kind of research where we understand what people take away from visualizations, we show people visualizations, we pay them a bunch of money on Prolific, and then we look at their conclusions, and then we analyze their conclusions, and we get confused, and then we try to understand something amongst our confusion. So this is a very lengthy process. And to ensure that y'all feel my pain, I want to give you an example of something we have to work with when we're doing this kind of research. Okay, so we showed people a visualization like this about reviewers and the papers, and this is what they wrote for us as their most intuitive takeaway. They said, paper A received a higher score from reviewer 1 and 2. Now, what do you think they are comparing in this visualization? Oh, you think? I'm going to move that up. And we were really confused. So we ended up having to ask them for a drawing of what they meant by this natural language description, and we still had two hypotheses until their drawing disambiguified it for us. So the first potential interpretation that we got was that they meant paper A received a higher summary score from the combination of reviewer 1 and 2. Right? They added the two white bars and they compared it to the two gray bars. That's potential interpretation 1. And it is also possible that they meant paper A received a higher score from reviewer 1 and it received a higher score from reviewer 2. So in this case, they're doing two comparisons. And then they noticed that these two comparisons actually happen in the same direction. Right? So because people are not very disciplined when they write these natural language description, it's difficult to understand where they are parsing their sentence, and we really have to rely on their drawings to figure out exactly what they mean. And that process just makes this research much harder and more effortful to do. And so that aside, when you ask people to describe what they're seeing, It's not exactly clear what they saw, and then it's also not clear what they're trying to tell us. But even then, let's just imagine we have generated enough insights. Me and my students have put in enough thousands of hours into this work, and we now know how people will verbally conclude their takeaways from visualization. Let's say we have that problem solved. Okay, now it's time to build a natural language interface. So what happens then is that when we do implement a natural language interface that allows users to input natural language queries, that input can still be ambiguous and underspecified. And that is a problem that we're trying to solve right now. So I'll give you an example of what I mean. So let's imagine we have a data set with just 4 variables, okay? So in this data set, our variables are movie names, box office, user ratings, and movie length. So this is a data set about movies. And then let's say our user inputs this query to say, please compare the popularity of movies A and B. Seems pretty easy, right? We can probably do it if someone asks us to do this analysis. But as a computer, you want it to be very specific. And then as a computer, you'll have many questions like, what do you mean by popularity? I see that we have box office and user ratings. Do you mean a combination of the two? Do you want to combine them equally, or do you want to do a 4-6 splits, right? Many questions that users don't realize they might need to specify when they're trying to have a natural language interaction with their system. Or they could ask questions like, compare the popularity of long movies. You're like, great, I have a variable called movie length. I know exactly what a long movie mean, or maybe I don't, because does long movies mean movies that are longer than average? Does it mean movies that are longer in the top 10 percentile of length? Or does it mean anything over an hour, right? So we have all these linguistic ambiguities we have to deal with when we develop any natural language interface that allows users to input. And so what our approach now is to try to resolve some of that ambiguity by showing people a visualization that best answer their queries. So we're doing some design studies work where we are showing experts and novices, Tableau users and non-Tableau users, just ambiguous queries, and we're asking them to help us draw and design visualizations that they think would answer these queries even if these queries are potentially ambiguous. And we synthesized their response, and we created a database of visualizations across different orientations and encodings and annotations and interactivity, among other things. And we have like our top N list of the most recommended visualizations, which we then verify and test. So we would show people on analysts on the internet questions like, if you see this query of comparing a highly rated book with a similarly highly rated book with respect to price, would you rather see this visualization or this visualization or this visualization or this visualization? So, and then we created a ranked list, which we're trying to implement with Tableau's Ask Data interface to see if we can create a mapping of which ambiguity is best resolved by which visual expression. And of course, you can read more about this. Oh, and here the answer is the top left one, but you can read about the specifics in the paper, and I'll be lying if I know if I say I know every detailed mapping in this paper. Okay, so coming back to this, hopefully these examples that show convinces you that there's a lot of work that we can do because language is difficult, and interpreting it is only really the tip of the iceberg. And along with these examples showing you that what patterns people see in the visualization is hard to predict, there's a lot of research opportunities in this space. I'm hoping to have conversations with you all to talk more about it tomorrow. And in the grand scheme of things, I want to finish with one last thought, is bringing this back into the real world. Beyond building interfaces and building systems, how can the process of understanding the visual and linguistic components of this model that I'm hoping to build help us in the real world? And I offer you a case study on criminal legal reform visualizations. So what I'm trying to say is that we can understand viewer perception and interpretation because that will allow us to design more trustworthy visualizations. And before that, I want to give you some really quick background because the US criminal legal system is very complex. And legal professionals like prosecutors or analysts from that district attorney's offices, they have to make a lot of decisions every day. But the complexity and the scope of these decisions, they are not always communicated to the general public. So I have a flow chart for you just to give you a sense of how complex it can get, right? You don't need to read anything on this visualization. I just want you to feel overwhelmed because this is overwhelming. And a lot of biases and discrimination could happen in this process. And the opaqueness of this process is causing the public to lose confidence and lose trust and lose faith in our criminal legal system. Right, so because of this, there's growing demands calling for change, and the district attorney's offices and prosecutors, they play a major role in this. And there's some group of prosecutors calling themselves progressive prosecutors. They're leading for change through data transparency and data dissemination. And this actually for them means a lot of online data dashboards. So this is where you see literacy is very important. I want to give you some examples because you can see that the district attorney's offices took very different approaches to create this dashboard. So this is one I found from the Multnomah County in Oregon. And then this is one from Lake County in Illinois. And then here is Yolo County in California. Couldn't find one for Santa Clara County, so, well. Anyway, and then so 3 all on the same page, so you can kind of compare and contrast. They use different color schemes. They use different amount of text on their dashboards. And what we did is we want to understand how does sharing criminal legal data via these dashboards might impact public understanding and trust in the legal system. And we asked people simple questions like, how much do you approve the DA looking at this? How much do you understand the information? Or how much do you trust the data? And this is some very, very preliminary data we very recently collected. And you see there seems to be some differences in these ratings, right? The way that the district attorneys choose to communicate data can not only impact public understanding, but also change the perceived approval ratings of the district attorneys. And now, so design of visualization dashboard matters, but quick note that this is all correlational, so lots to be done still if we want to understand how we want to build trustworthy visualizations. And on the topic of trustworthy visualizations, I've been thinking a lot about what does it really mean to be trustworthy. And I came up with this idea of calibrated trust, where you want people to critically read a visualization so that they are not over or underweighing the evidence they're seeing. But then the question is, how do you get people to critically read a visualization? How do you design visualizations to drive critical thinking, to increase calibrated trust? I don't have answers, but Lily, who is talking right after me, is gonna have something to share on critical thinking. So I'm very excited to learn from her. But from me, I think we just wanna kind of stop here to just be satisfied for now about how we know there are signs about visualization. Design influences trust and decision making, and that can has implications for policy and technology design. And there's anything y'all want to take home with you today from me, and that would just be the simple message on the bottom here, to design your visualizations thoughtfully. That's all I have. Thank you.
All right, thank you so much. What questions do we have for Cindy?
Hi, amazing talk. I guess one question I have is that in the first part of your talk, you mentioned intuitive takeaways, and I was wondering how you try to compare, I guess, intuitive takeaways across like different people and different models.
Yeah, intuitive takeaway is a tricky thing to elicit from people, because some people have verbal takeaways, that they have a verbal conclusion. Some people see visual patterns. So we haven't gotten to a point where we can model these individual differences. So I have a lot to talk about with Mary. But for now, we're just asking people to type, and we prompt them things like, what's the most salient thing that stands out to you? We also try to prompt, what are your top 3 conclusions? And we compare these, and there are some small differences by the effect of prompting, and we would be excited to look more into the individual differences part. Thank you.
Thank you for the talk. You were talking about creating data visualizations to sort of uncover ambiguities, which I think is a super cool idea. I was wondering, I'm a little bit concerned about creating data visualizations to resolve certain types of ambiguity, because from your examples, a lot of those ambiguities are actually implicit decisions. Like, how do I define what a long movie is? And when I just look at a data visualization, that is probably something that I often miss. Like, the model has made a decision that this is what it defines as a long movie, but from the data visualization itself, I will not see that decision point. So I was wondering, is that something that you're looking into, like as communicating those decision points, like making those more explicit or,
Yeah, that's a really great question. I think it has a lot to do with the critical thinking component that we're thinking about, which is visualization is not by any means objective in any way, and we want to surface that non-objectivity to the users somehow without overwhelming them, but giving them some patterns that they kind of understand where it comes from. So we are actually trying to leverage this desirable difficulty thing that Rob was talking about this morning, where if we can slow people down a little bit so that they can take some time to see where this data is coming from, where in the data cleaning pipeline things are omitted or added, to kind of surface that through either annotations or interaction, that might be one way we can get people to see some of that non-objectivity. I don't think we're trying to resolve ambiguities in the visualization, but rather in people's description of what they see in the visualization. I think you could see many different things, but that key message should be very clear, because you're just using visualization as a communication device after all. Now, how to do that ethically, I don't know, but eventually we'll look into it. Thank you.